I'm going to ask you to get out these notes from 10.5. So you should have these notes. They kind of look like this. Yes, 2 pages. And so what we've been doing is kind of working on 10.4. But 10.4 and 10.5, they're a little bit mixed up. Everything that we're working on here is woven together, so it's kind of hard to separate them. And we're working on equations. And ultimately, the goal of the equations is to get to this. 10.5 is we want to solve word problems, applications, real life situations that involve equations that have fractions in them, the rational expression kind of equations. So this is, I'll try to summarize it all nicely at the end, but we're looking at several different things here. So we first started solving them by graphing them. And then I showed you how to solve one by algebra. And then I'm going to show you how to solve some in word problems. But we're going to take a little bit of a detour here because the book underemphasizes the really important kind of equation problem. A rational equation that's a proportion. And that is a type of algebra that almost everybody does. My daughter is an artist and she has a painting and she wants to scale the painting up to a much bigger size. That's a proportion, and she has to use these fraction equations to do that. Cooks that do recipes, read a recipe book and it makes a serving for 6 people, and you're having a party and you got to serve 20 people. That's a proportion. You got to scale that by an equation to solve it pretty simply, but it's an important kind of equation. So I've got 2 goals here. The first goal is a contrast. We have been solving equations. Solve fraction equations. And the strategy, if we do it by algebra, the strategy is to kill the fractions. I'm just being very violent with the words here to kind of emphasize. We want to kill out the fractions, kill off the fractions, because it makes the equation easier. That's going to be our strategy on all of the equations that we solve, provided that we're solving by algebra. Okay, now it turns out these fractions equations, there are 2 kinds, easy kinds and hard kinds. I'm going to write down 2 kinds. Notice fraction equation, 4 plus 3 over x minus 4. These are both equations with fractions, and I want to talk about them for a minute because you need to be able to classify and characterize the distinction. What distinguishes the green equation with fractions as different than the blue equation with fractions?
We have different denominators on A, more than one different denominator.
Okay.
Yeah.
These don't have denominators, but I'm going to put a denominator on them. I'm going to make a 1. And I'm even going to make, this is the one we did a few minutes ago, but I'm going to make this one even harder. The blue one is a fraction equation. The green one is a fraction equation. What are things that would differentiate that? How would you distinguish between the green type of equation which is an easy kind. It's easy to solve this one. There's a shortcut. And the blue kind, which is not easy. There's no shortcuts. We have to solve it like we did. This is the blue solving. That's the one we solved already. Okay, so we want to be able to differentiate them because with this kind, there's no shortcuts, but with the green kind, there is. And you have to be able to identify them. So what are some distinguishing characteristics between the green and the blue?
Well, like you said, the green is going to be easier because there's less steps.
What is it that makes the green one easier? How would we describe what is it about the green one that's easier?
We have an addition.
Okay, the addition. That's really the distinguishing feature. If you have an addition, how many terms do you have? We got 2 terms here, and we got another term on the other side. So this equation is made up of 3 terms. How many terms is this equation made up of? Only 1 fraction on one side and 1 fraction on the other. There's only 2 fractions, a left side fraction and a right side fraction. This one has a left side fraction, but then it has a right side with 2 terms. So that is a simple way to characterize the difference between the blue and the green is the harder ones have many terms. These easier ones have only 2 fractions. A left side fraction and a right side fraction. So it's a fraction equals a fraction. The blue one is more complicated than that because of the plus. You might have a minus in there, and once you have pluses and minuses, you're adding many fractions, more terms, it's more complicated. So the green one is a fraction equation with a special name. We call this type of equation a proportion. You've probably heard that word used in different contexts where we say, oh, this is proportional to that. And whenever you have a something is proportional to something, it's going to be one of these fraction equations. But it's a simple fraction. It's 1 fraction on one side, 1 on the other. Now the blue one, it's not simple. We have to kill the fractions. So we have a lot of steps. The green one has a shortcut. Now what I want to do is I'm going to solve the green one really fast. No. Maybe you guys can figure out the shortcut. Let's turn in your note packet. So we kind of set up the story here. And for a moment, you're going to have 10.5 skill builder. In MOM, there's a 10.5 skill builder that is going to focus exclusively on these proportion problems. There's going to be algebra proportions, and there's going to be word problem proportions. And then there's 10.5 by itself. That MOM is going to have fraction equations and word problems with fraction equations. But let's start on the easy kind, the skill builder here, and study proportions for a minute. So ratios and proportions, just some vocabulary. a ratio. We've talked about it before. That is the root of our word rational. When we talk about rational numbers, we're really talking about ratio numbers. And ratio numbers is just a name of a fraction. Okay, so a ratio is made up of a fraction. A proportion is an equation with two ratios. So I have 3 examples down at the bottom. Are all 3 examples proportions? Okay, a proportion is an equation. Well, this is an equation, an equation, an equation. They're all equations. So all of them are equations. Proportions are equations, but proportions are equations with 2 ratios. How many ratios does this have? 1 on the left, 1 on the right. So yes, this is a proportion. How about the middle one? There's a fraction on the left, a fraction on the right. The answer to that is yes, that's a proportion. How about the last one? Is that a proportion? Does this satisfy the definition of being a proportion? Proportions are equations with 2 fractions. This one doesn't have 2. It has 1, 2, 3 fractions. This has many terms. So nope, that's not a proportion. Now, can we solve for x on the second one and the third one? We can. It's just that the proportion in the middle has an easy way to solve, and the many terms equation, it's solvable. It's just going to have a lot of steps. That'll be more challenging to solve. All right, so but I wanted to introduce you to this word proportion, kind of drill down a little bit deeper, help you conform that. So when you see these equations, anytime you have a chapter 10 equation to solve, you want to categorize it in your mind. What type is it? Is it a proportion or is it not? Because there's an easy way to solve proportions. If they're not proportions, then you don't have the easy way. All right. Let's look at how we would solve these. Technically, this is a proportion equation, but it's also a fraction equation. Now, we can use the strategy. I'm going to solve it the long way, and then, oh, sorry, rewind. Go back 1 page. I forgot to tell you something about proportions. Proportions are something we use to build common denominators and to reduce fractions. And they behave in a certain way. So this is kind of an odd principle, but it is an interesting coincidence here that if you take 12 times 3 and you cross multiply, some of you may recognize that word from your past. 12 times 3 is 36. That is going to equal cross multiplying the other way. So you're going to get an equation with equals in the middle, and 36 times 1 is 36. If you have an equals proportion, the cross multiply is always true. For example, like 1/2. Does 1/2 equal 2/5? Well, 1/2 is like 50 cents. and 2/5 is 40 cents. So no, they don't equal. And we see it even when we cross multiply. 2 times 2 is 4. And 1 times 5 is 5. That doesn't equal. So these two fractions are not proportional. Cross multiplying is always true when you have a proportion. So if I go 2 times 2, that's 4, and 1 times 5 is 5. They don't equal 4 times 5. So the fractions don't equal. They're not proportional. Now we can use this cross multiplying as our shortcut for solving proportions. So on this problem, I can cross multiply 2 times x equals in the middle. Cross multiply the other side. 9 times 8, 72. Now when I cross multiplied, where's the fractions? Fractions are gone. That's one of the sweet, simple ideas about this cross multiplying tool, is that you can get rid of your fractions really fast. But it's only true for proportions. And then we can solve it. Divide by 2 and we'll be done. On this one, you can't cross multiply. Because it's not a proportion. You have to have just 2 fractions, one on each side, and that's it. And you can cross multiply. If you have many terms, it's not a proportion. Cross multiplying does not work. So let's study this and practice this for proportions. This first problem I've got here on the next page, solving, is that a proportion or not? Question mark. Proportion. Yes or no?
Yes.
It is. So if you can say yes because you only have 2 fractions, one on the left, one on the right, you can cross multiply. Now, normally what we have to do is kill the fractions, so we've got a lot of work to get rid of the fractions. But if we do the proportion strategy, we make our equation by multiplying one side. Well, I'm sorry, by multiplying across one way. Now, you wouldn't have to write this down. You could do this in your head. But I want you to see my thinking. So I'm multiplying 1 times the group a plus 6. On the other side, I'm going to multiply. So equals is in the middle. And I multiply across the other side to make the other side of equals. 3 times a minus 4. Do you guys see the cross multiplying? Where's the fractions? They're gone. Now it's easy to solve. All we have to do is get rid of parentheses and get a by itself. Most students, once you've done this a couple of times, you're going to skip that step because you can do all that in your head. 1 times a plus 6 is a plus 6. When you cross multiply 3 times a, you get 3a. Cross multiply 3 times 4, we get minus 12. So many people will do this part mentally. But if it's a little confusing for you at first, go ahead and write down the cross multiply step so that you don't make any mistakes here. Now, how do I get a by itself? There's too many a's. I can't get a by itself when they're on the left and the right. So I'm going to minus the a's on both sides. Okay, so 3a minus a is 2a left. I've only got 2a on one side. Next, I'm going to get a by itself by adding 12. So I got 18 equals 2a. And I'm almost there. Divide by 2. 9 equals a. All done. Except for one little problem. It comes up sometimes, so we have to be on the lookout. Are there any bad A's? Any restricted A's? Remember, these are fractions. We can't divide by 0. Is there a bad A that would make us divide by 0?
-6.
Right here. This fraction in the original equation, if that was -6, that would be 0. I'd be dividing by 0. So we have a restriction here that we have to take a note of. A is not allowed to be -6. Now, technically, I should have done that first. But this happens sometimes. I get the restricted number, I do the algebra, and in some unusual circumstances, the answer comes out to be this. If some weird equation came out and a equals -6, can a equal -6? No. So I would have to throw this answer away and say no solution. So we do need to pay attention to the restricted domain numbers, because occasionally they crop up in our algebra answers. And if they do, we got to throw them out. But 9 is not a restricted A number. 9 is a good answer. That checks. We're all good. We can just move on. All right. Second one, is it a proportion? Somebody besides Christy, she called the last one.
Yes.
It is. Yes. And because it's a proportion, we have an easy way to solve. Our easy way to solve is cross multiply. Now you do have to have a proportion. You do have to have an equals. Don't cross multiply expressions. This is a weird gimmick. It's a shortcut gimmick. And it only works on these proportions. And so you have to be working an equation. But when I cross multiply, I would have 4 times x plus 3 equals in the middle. Cross multiply the other side. 1 times x minus 1. Now, many of you can skip that because you can do that in your head. And I'm okay if you do skip it. You should have 4x plus 12 equals x minus 1. And then we can solve. Let's get all the x's on one side. And then let's minus the 12 on the other side. And then we can divide by 3. We got x by itself. Now, the only answer to this equation, it's not a nice answer. We're coming out with -13/3. So that would be the number that I could plug into this that would make it true. So this is kind of following in line with what we learned before. On the harder equations, we want to kill fractions. And because they're proportions, we can cross multiply and the fractions are gone when we cross multiply. So that's a really sweet, easy, convenient thing. But it only works for proportions.
So the restrictions for this would be -3 and +1?
Good. I'm not paying attention to my own teaching here. It's a good idea to check your restrictions. So when you get an answer, check your answer against the restrictions. And so Christy called out, that's correct. -3 is a bad x, and 1 is a bad x. And my answer is not 1 and not -3. So I have an answer that's acceptable. That's a good answer. Okay, pretty good. Let's go to the next set of problems here. I want you to solve it. 3 over w plus 7 and w plus 10 over 7. You guys find the solution. Okay, let me pause you for a moment. In class, I would have walked around and checked at this point. Cross multiply. So this side is easy to multiply. 3w plus 21. When I cross multiply here, how do we have to multiply this?
FOIL.
Exactly, good call. We have to FOIL that. So if you didn't FOIL, maybe it's a good time to erase and go backtrack a little bit. Well, we should have 7w plus 10w is 17w plus 7d. Now what?
Shouldn't we set it to 0 so we can factor?
Exactly. It's quadratic. We have to have it equal to 0 for it to be solvable for us. So I'm doing 2 algebra steps at once to get rid of both of those guys and make that equal 0 really fast. 17w minus 3 is plus 14w. 70 minus 21 is plus 49. Okay, factor. I hope it factors. Can you think of 2 numbers that multiply to 49 and add to 14?
7.
Yeah. So the 2 factors are duplicates of each other. They're repeated. So technically, I would like to find 2 answers, but we don't always get to. We have 2 equations, but the second one is just going to repeat the first one. So when I minus 7 on both sides, I get minus 7 equals W. One answer and got it. Everybody good? Any questions or comments or thoughts? I'm delaying on purpose here.
Are we forgetting the restrictions?
We are.
Solution.
Does this equation have any bad x's?
-7.
X is not allowed to be -7. If I put -7 here, Negative 7 plus 7 is 0. 3 over 0 is undefined. That is a restricted x. It is not allowed in the domain. But wait, I solved it, and it tells me that w equals negative 7. What are we going to make of this? When we put negative 7 in here, it's like putting milk in your gas tank. It's going to break the equation. So for some strange reason, because of the pattern in the numbers, I got this value, but it's not allowed. I don't know why I put x. I mean, I do know why I put x out of habit. This is a w problem. W is not allowed to be negative 7. So what we have to do is throw this away. We can't use it. It's the restricted number. And there's only one answer for us to choose, and it's the bad w number. So we're going to have to summarize by saying, oh, there's no solution on this equation. That does not happen very often. But if you're not in the habit of checking the domain restrictions, it'll catch you off guard, and you'll give me the answer when it's not accepted. So you do have to kind of check those restricted numbers. Okay, one more of these. I'm going to pick up the speed a little bit because I think you got the idea. Is it a proportion? And the answer is yes. And because it's a proportion, we can cross multiply. So I multiply across one side, I get x squared. I put equals in the middle and then multiply on the other side, and I get 36. How many solutions are there? It's quadratic. We're looking for 2 answers. Now there's a method that we didn't really develop because it's not a high priority method where you can take the square root of both sides. But I'm just going to stick with our quadratic strategy. If it's second power, what do you have to make it equal before you can start?
0.
Yeah. Okay, so x squared minus 36 equals 0. And then we try and factor. Hey, this is factorable. We have a difference of squares, so we get plus 6 and minus 6. And I'm going to get 2 equations that I can solve. And when I minus 6 on both sides here, I get x equals negative 6. On the other one, I have to plus 6 on both sides, so I get, for this one, x is 6. Are both of these numbers approved answers? We didn't really take note at the beginning, which maybe we should. Maybe I'm being a little lazy here, but you do need to check against restrictions. X is not allowed to be 0. So these 2 numbers are okay. So hopefully that seems like it's pretty easy. Solving proportions, they're supposed to be easy. Cross multiply and the fraction's gone. We like them because with one simple shortcut, no fractions. One simple shortcut, no fractions. Now here's where they start getting more relevant. This is like my daughter's story where she was working on a picture and she had to scale the picture up, or maybe the picture has to be scaled down. It could be a garden. Somebody's working on a garden plan and it's in meters and they have to switch it to feet. It could be a computer graphic. You need to get the graphics that are in real life this size, and you got to get it down in this size in the computer. Well, when these two shapes are the same shape, we call them proportional. The shapes are the same. The proportions of the size are different, but proportionally they're the same shapes. So we can solve this with algebra. We're missing a side here and we need to know what it is. Now, proportions are based on two fractions. So I'm really picky about explaining variables. A equals the side. But we have another thing we need to get clear on. Because with proportions, you got two fractions. And you can have two fractions, but what if one of them is upside down? If you have one fraction one way and the other one is upside down, your equation will be wrong. And so in order to get them both the same way, you need to establish in your mind what goes on top, what goes on the bottom. So we need our ratio in words. That will force you to make sure you put the same numbers on the top that you put on both fractions and the same number on the bottom that you put for both fractions. So I'm comparing the 4 to the 10 and the a to the 16. That's the proportion. Now let's give words to these things. What words would we associate with the 4 and the 10? What do they have to do with the triangle? Charles, were you going to try and answer that?
They're like the bottom or
The
like
bottom.
the denominator, yeah, the fraction.
So it's the bottom of the triangle. It doesn't have to be the bottom of the fraction.
Mhm.
We can put these numbers on the top of the fraction.
Mhm.
But if we decide in words, our fraction will be the bottom of the triangle. And how would we describe this other thing on the triangle?
Are you talking about A and 16?
Yeah,
The height?
it could be a height. Now, actually, this isn't really a height in this case, because a height would have to be a square corner. This is a little bit
So length?
slanted over. Okay, it is a length, but so is 10. 10 is a length also.
We can call it width times length.
Usually the width and the length are at square corners. And so this is not perfectly square, it's a slanted. But if 10 is the bottom, we could call 16 the side. You might call it a slant width or slant length, but I don't want to make it too complicated. You just have to have two words in your head that distinguish between one number and the other. And for me, that's what's working, side and bottom. Okay? Now I need a proportion equation. So I'm going to go A over 4 equals 10 over 16. How am I doing?
Wouldn't the 16 be on top?
Correct. Now, would this be an easy mistake to make? That is a very easy mistake to make. Put one fraction one way, have the other fraction upside down. It's a super easy mistake to make. If you're not paying attention to the meaning of top and bottom, then it's very easy to make this equation wrong. It's going to be upside down and it's going to ruin the whole equation. That's why I'm so particular and suggesting that you figure out words to explain what is what. That's how Rhiannon knew so fast, because the side is going on the top and 16 is the side. It has to be 16 on the top. 10 is the bottom number for the triangle, so we're putting it on the bottom of our fraction. In that way, our fractions don't get screwed up. And our cross multiplying is going to work just fine now. 8 times 10, it's 10a, equals in the middle. 4 times 16 is 56. Now we can solve for a. Uh, 56 divided by 10 is 5.6. So if we were putting a garden in our backyard and we wanted it to match this picture in the book, then we know, oh, we have to make it 5.6 feet for the back of our garden. If we had this design for a brochure and we were trying to put this picture in the computer, then we'd know we have to program the computer to be 5.6 centimeters. There's all kinds of applications to this, but because we've got proportional shapes, we know that that has to be 5.6 feet or centimeters or whatever. And I'm going to do that same strategy, but this one's not a picture. This one's words. And so I need a variable for my unknown. A manufacturer knows that during production, 8 out of 10 parts are going to be made defective. They'll just have defects in them. And they plan to produce 1,650 parts. Now, if you're making a gear, this is your part. It happens to be a gear. And somebody's putting that gear into their machine. And they order 1,650 parts. And they open up the box and they keep pulling out. And many of them are broken or they have defects on them. They're going to be mad because they don't have enough parts now. So us as the manufacturers, we have to solve that problem by maybe shipping them extra replacement parts or lowering the price, because we know that all of these, if we ship all of these, they won't have some of them will be bad, so we should lower the price for them. But if we don't pay attention to that, our customers are going to be angry because we haven't compensated them for bad parts. So how many can they expect to be defective? So let's let X equal the number of defective parts. And it's related to this order. We know that 8 out of 100 are defective, but we don't know how many is out of 1,650. Okay, now, so be picky. I'm picky about this. Explain your variable, but particularly involving proportions. And I do see a proportion. Here's a fraction. 8 out of 100. That's a fraction. And I see 1,650 parts and some undefective parts. So that actually is another fraction. This is a proportion problem. So if I figure out how to make my proportions, then I can get an equation. So we should always figure out our ratio in words. What are we going to put on the top and what are we going to put on the bottom? How about number of defects? compared to the number of the whole. So if we look at 8 out of 100, it's like 100 is the whole thing. So we have 100 parts, and the number of defects would be 8. So I could make a ratio of 8 out of 100. Now, on the next one, I have to figure out, where does the X go? Does the X go on the bottom or the top? Well, we've established the defects are the ones that goes on the top. And if I know that X is defects, then it's easy. I know X goes here. And then this is the whole order. 1,650 parts. Now it's really easy. I'm going to have a proportion. Okay, so let's cross multiply. 100 times X, and cross multiplying this way. 8 times 1650. I'm going to have to do some calculator pushing here. And we get 13,200. No fraction. The proportion started out with fraction. We cross multiplied, no fraction. We can solve easy here. The hundreds cancel. Hundreds cancel. We get 132. What does that mean? That means 132 defective parts in the order. Of 1,650. So if I were a manufacturer and I was manufacturing with this part, and some company sent me 132 bad parts, I'd be mad because I paid for all of this, but I don't have all of that. These are all broken. So I'd be upset. I'd want a refund, or so this company can compensate. Now that they know, they can send extra parts. Say, okay, let's give them 135 extra parts. That way we know that they'll be happy because they will have plenty of good parts. This is an example of proportions in the field of business and manufacturing. Here's another example, and the last example I'm going to do in the field of biology. So we've got a lake. And underwater, we have a bunch of trout. Now, how many trout are in the lake? The biologist doesn't know, right? You can't go down there and count them all. But this would be an important number. Maybe they're doing an eco study. Maybe something happened to the lake. Maybe it's got polluted and they want to see if it's affecting the trout. Or maybe it's a national park and they want to make sure there's enough trout for fishermen. Or maybe it's a trout farm and they're selling the trout for food. And so they need to keep track of their trout population. How can they do that? Well, here's a strategy. If you have all these trout, the biologist can go out there and he can go fishing. Can maybe take some nets or, fishing hook or something and catch the trouts. And when he catches a trout, he can put a tag on it. All right, so he went out and he caught a bunch of trout, 112 of them. And then he puts tags on them. So some of the trout now have tags and some don't. And if he goes back and fishes again, he's going to catch some of the old ones that have tags and some of the new ones that don't have tags. Well, inside of this is a proportion, because the ones that have tags are proportional to the whole thing. And so let's see if we can estimate the number of trout in the lake. So X equals the number of trout in the whole lake. All right, now I got to figure out my ratio. What is the ratio I'm going to use in words? And it's based on this information that I'm given. When he went fishing in the whole lake. And he caught 112 that have tags now. So this 112 is related to the whole lake. So I think there it is again. 82 were caught. That's like the whole group, and 32 had tags. So that, I think, is our strategy, to compare the tags to the whole lake and the tags to this whole batch he caught. So I'm going to say the words this way I don't get my fractions backwards. I'm using the word whole kind of loosely because on the first fishing experience, there was 112 fish that he caught and tagged. He threw them back in. So those 112 are now swimming in the whole lake. So the 112 are part of the whole. So that 112 is a ratio with the whole lake, which I don't know is X. You know, a month later, this person went back and he caught a whole group of fish, 82 of them, and not all of them had tags. Only 32 had tags. So that's got to be proportional to 32 tags over 82 fish. So this 32 out of 82 is proportional to all the tags with all of the fish in the lake. Well, this is a proportion here that we can solve to estimate how many fish are in the lake. I'm going to cross multiply 32x, and I'm going to cross multiply the other way. 112 times 82, and I get 9,184, and I can divide by 32. That comes out to be about 287. So I can use this number to predict how many fish are in the whole lake. And so, you know, depending on the size of the lake, or we can know, is that enough fish or not enough fish, or, you know, how is the population doing? Are they healthy or not? And so we've got just a simple solution to this biological problem using proportions. So when you're doing the 10.5 skill builder, it's going to be all about these proportion equations. I'm going to quit there, and I'll have to do a little bit more of this on Monday. So Christy, you hung in there all the way to the end. Do you want to ask me any questions about the proportions?
So how we find the ratio is by what's being compared in the word problem? Is that
Right.
how
We're looking for two things that are being compared to each other, like tags to the whole group, like defects to the whole set, like the bottom to the side. So we're trying to find something that we can make into a fraction, and we're comparing two different things. So ratios are usually comparisons of two different things that we're relating together, like miles per hour when we do slope. We're comparing miles to hours. Here we're comparing side to bottom. Here we're comparing defective parts to all of the parts in the box. And here we're comparing like the number of tagged fish to all the fish.
Mm.
So those are little clues that we're trying to sort out when we run into proportion problems. Can we make a fraction that's comparing two things?
Yes. So the whole will always have the variable then.
Not necessarily. In this one, the whole was 1,650 because that was the whole order. And the X was the number of defects. So that was just part, the number of defects is part of the whole thing. But in the fish problem, it didn't work out that way because there's 112 of these tagged fish, but they're not the whole lake. So the 112 was the part, the tagged part. And that 112 is just part of the whole lake. So X was the whole in this problem. So I put the whole lake, the number of fish in the whole lake in the bottom. So you kind of have to sort out the meaning of what's what. What does the X mean? Which piece of your ratio is it? And that's why it's important to have it clear in your mind what the top means and what the bottom of the fraction means so that you put the X in the right place.
Okay, that makes sense.
Cool. I bet, especially as you start reading them and practicing them and trying a few, the more you do, the more it'll start clicking in.
All right. Well, thank you.
Yeah, thanks for sticking around.
No problem. Enjoy your weekend.
Yeah, you too. See you Monday.
Okay, bye.
Bye-bye.